Welcome to the June Moddable community call. We do these once a month to update folks on what's going on in the Moddable SDK, in and around the Moddable SDK. We record these so folks can see it at their leisure throughout the month. This month, our agenda will be, as usual, kicked off with a look at the Moddable SDK. The latest version for June is 3.9.4. And then we will hear from our special guests from Juniper Technologies, Daniel Ashcroft and Lawrence Kincheloe. They've got a new product they're launching. I think it's their first one. It's a hardware product called Twig for agriculture monitoring. The product is pretty cool, and the philosophy behind it is maybe even cooler. It's a very open product. And so they're going to talk about the different aspects of that. And then if folks want to hang around afterwards, we can just talk. We usually turn recording off for that, so you don't have to be super careful. A little bit of news, just things going on. The second edition of ECMA 4.19 is hopefully imminent. The draft has been complete now for about a month. And it's on the agenda to be approved at the General Assembly of ECMA at the end of June. That'll be great. That's got a ton of stuff in it. We'll talk more about that at a future call. Moddable is going to be participating in the Sensors Converge show in Santa Clara next week, Wednesday and Thursday. We'll have some really great demos. And, if for some reason you happen to find yourself in Silicon Valley, drop in and say, hey, we'd love to see you. Our July release will be a couple weeks late. We just want to let everybody know that ahead of time, and that's just because of summer travel plans. And we didn't want to rush it and get sloppy. And so this call will also be delayed a little bit for July. Let's talk about the SDK. We do a release every month. If you've started us, I think on GitHub, you get a notification of that. Our goal here is to have something that's stable and a recommended update so that people who are deploying products, our commercial clients, can grab that and know that that'll be a stable point for them for their updates and their releases. They always come with detailed release notes so that every major change and a lot of the minor changes are noted so that you can read about that. If there's any incompatibilities or things to update, those are also noted there. So I always recommend giving that at least a quick scan to see if there's any fixes or new features that could be interesting to you. Thank you to our contributors. We're always happy to have people making contributions large and small. I was recently reading a book that talked about the Homebrew Computer Club that actually, from back in the 70s, it's the stuff of legend, but they met not that far from the Moddable office. And one of the founders, Fred Moore, always encouraged the members who attended to bring back next time, or bring back more than they take. And so there really was a goal to have kind of a virtuous cycle of people sharing. And I thank our contributors for kind of honoring that spirit and contributing their knowledge and their skills. So let's look at what's in the Moddable SDK this month. Almost always some new hardware support so that people can run on the latest chips and boards. We've got a couple of ESP32 C3 boards. This is a RISC-V board that is kind of the lowest cost part from Espresso now, more or less a replacement for the ESP8266. I think, in fact, I know Lawrence, one of our guests, was instrumental in getting the C3 port of the Moddable SDK done, and I suspect that he's even using it in some of his work. So this is kind of the standard dev board from Espresso, so that works now. They also have one that they used for some demos with Rust that has a built-in IMU and a temperature and humidity sensor. So if you're looking for something that's kind of all-in-one, that's working now as well. We've got a couple of ESP32 S2 boards. This is one from Adafruit, and it's USB native. It's really tiny. It's got 2 megs of RAM. This is a WEMOS board. It's roughly equivalent. The biggest difference is it has all of its pins exposed. So if you're going to connect lots of stuff to it, and you're happy with a soldering iron, this is the one for you. Just a word of note, we bought some of these and we got off of Amazon, and got a bad batch that Wi-Fi didn't work. So do try to buy, I think it was a no-name one, and you should really buy like the branded one from a reputable supplier, who I guess isn't Amazon. But they're really nice boards when they work well. We also updated our M5Stack Core2 port to support 4 megs of PS RAM. So that's 16 times more RAM than was supported before. And the M5Stack Fire as well now supports PS RAM. And one of the things you've noticed is that we seem to have gotten under control support for PS RAM on these devices. So as additional boards come out that have that extra RAM included, it should be really straightforward to support that moving forward. So that's really great for bigger projects. By far the most obscure feature is in XS 14.1 is support for garbage collection of keys. This is really important for some uses, although generally not embedded. I mean, we've never needed it before, but web browsers have done this forever. It's kind of an expected, if not strictly required feature of JavaScript engines. And it does, in certain cases, avoid running out of key space or memory space. And it let us implement the one proposal that was in ECMAScript 2023 that we didn't in XS 14, which is called symbols as weak map keys. So that support's there. It's disabled by default, but super easy to turn on. So if you have a use for it, it's ready to go. We have found that probably half of our developers use TypeScript. It's informal, but seems close to true. And so we continue to improve our support for TypeScript. This release is no exception. The changes are subtle, but if you bump into them, you'll really appreciate it, that it just works now. For those of you who haven't used TypeScript with the Moddable SDK, super easy to do. Instead of having a .js source file, you just put a .ts source file. You add one file to your manifest so that you get the type declarations included, and that's it. Building and debugging work exactly the same. And TypeScript support has really been a community effort. The Moddable team has done most of the work on the tooling, but the community has done almost all of the work on the type declarations. And that's been really helpful. There's a lot there, and it's great to have people helping out and creating those, and then updating them as they find corrections are needed. Another nifty little feature, I think this was actually requested by Thorsten, is that in xsbug now you can look at the contents of buffers. So here's a very simple little example. Embedded developers tend to use buffers much more than web developers because we're working with binary data and downloads and registers and all sorts of strange things. So here's a simple example where we create a uint16 array and a subview on that. And you can see on the left in the debugger, the uint16 array view displays the values of all those, as you'd expect. And if you open up the buffer, which points to the array buffer, which is the backing store, it displays a hex dump of that. And so you'll see that view is all 32 bytes of the array buffer. And you can also see if you squint that it's all in little endian byte order, as it should be. So again, this is just super helpful in speeding up debugging and analysis of things, so you don't have to manually instrument your buffers when you're debugging. So that's just there and just works in the latest release. Audio is something we keep coming back to. A lot more of the boards these days come with audio support. As you know, the Moddable SDK, we really love user interface. We've done a ton with screens, and audio is a really great complement to that. So we previewed last month a new MP3 decoder. Sort of inspired by StackChan, which had some really good uses for it. But it's a general purpose MP3 decoder. We've kind of shaken some of the bugs out of it in the last few weeks. It's based on an open source port of the lame decoder. Supports all the MP3 modes that we could find. Very good performance. Pretty light on memory. Won't bring you to your knees in terms of taking the device out. We've actually done tests where you can run 2 instances of the MP3 decoder at the same time on an ESP32, and it works just fine. So there's really plenty of overhead left. There's APIs to play data from Flash and to stream over HTTP, and more importantly, HTTPS, because a lot of web services these days refuse to deliver in HTTP. So it's probably for the best, but that does complicate things a bit. And we had built on top of that yeah, there we go. And the SomaFM app is now in our repository as well, and debugged so that it does the right thing. And who knows if you can hear it or not. Never get these things to work right. But in theory, that would be playing. And the cool things when we get this recording right is that there's almost no startup latency. It's also got a very nice touch UI, as you can see. And so if you're looking for how do you build something that looks and feels more like a mobile app that runs on embedded, this app is a really great place to take a look. Let's see, next slide. This is, oh my God, there we go. So we did, as part of the MP3 work, we did support for text-to-speech using the 11 Labs text-to-speech engine, which is very cool. It builds on the MP3 streaming. It runs over TLS. And the StackChan folks, I'm going to play this in case it actually is making sound. Can't tell. I did turn it on.
My name is StackChan.
The StackChan folks had this integrated into StackChan and talking within just a few days of our release and making it available, which was awesome. Congratulations to Tanaka-san for that work. And it really shows that, embedded JavaScript just makes it so easy to kind of glue these pieces together and, keep the dependencies fast and light. My colleague, Michael Kellner, was kind of motivated by this and spent some time working on audio for the Raspberry Pi Pico. And so that now supports I2S audio hardware with all the exact same APIs and features that we support everywhere else. To use that, you need to update your Pico SDK, and if you're using xsbug, that's just one line, super easy. And if not, it's like 2 lines. But so that's Raspberry Pi Pico audio support is now there. I will play this.
11 Labs text-to-speech running on the Raspberry Pi Pico with help from the Moddable SDK.
Mix otherwise. And then Mike had added on top of that, kind of inspired by the StackChan stuff. He actually took the StackChan code, slimmed it down a little bit to squeeze it into a Pico, and has that running. And so you can see here with the, let's see.
Good morning, world. Have a wonderful day.
With the same StackChan animations and audio sync to the mouth and the eyes bouncing.
Good morning, world. Have a wonderful day.
It kind of started to work. So something kind of cool, the portability that comes out of things built in the Moddable SDK, that StackChan was never built for a Raspberry Pi Pico in mind, but actually can run there without too much effort. So very cool. There's a lot of other stuff in the release. Check out the release notes. If you want to get the release notes, just star us on GitHub. And that's the release. And so now I will turn it over. I'm going to introduce our special guests, Daniel and Lawrence. They're the co-founders of Juniper Technology. I've had the pleasure of working with them online through their contributions to the Moddable SDK and their questions and the things they've published. And they both have some really great skills. And from what I've learned about their vision for their company and their product, I think they have a really great direction and kind of philosophy behind the product. So I'm looking forward to hearing what they have to say. So Daniel and Lawrence, over to you guys.
Yeah, make sure that you can hear me okay?
Yes, perfectly.
Awesome. I'm going to do the boring share. I'm going to share the website and then our dashboard, and then Lawrence has some amazing slides of the physical product. And I'll give a general preface. So myself and Lawrence started this company after I had some experience working in ag tech. In particular, working with compliance and going out and visiting farms, both for leafy greens and other roots and vegetables. One of the primary concerns we ran into a lot of times is that these large agricultural enterprises will spend millions of dollars on equipment, and then there will be one isolated machine sitting off in a closet where all their data goes to, because either their data provider doesn't have a cloud platform or they won't allow them to remove their data and access it anywhere else. So it's a highly, highly vendor locked in industry. Once you kind of go a direction, for instance, that is a direction you have to go. And it is really unfortunate because that's the backbone of our nation, really, is our ability to have food supply and transportation. So this for me was a pretty good opportunity, knowing how to program, to kind of look into and see if we could create products. Originally, our first go-to-market product was going to be a fertigation pump, which Lawrence and I did some designing and some programming for a peristaltic pump. But it's a very large undertaking if you think about using dosimeters and stuff to actually do on-the-fly dosing. So we simplified that down for our first iteration. We actually did environmental monitoring, which is kind of like the bedrock amount of data that's necessary to do anything agricultural related. Our general premise, and this is like our big calling card right here in the middle of our website, because we really believe this, which is that whenever you put data into the cloud, that you should still own that data. So another big issue in ag tech is a grower's formula for growing their fruits, vegetables, and their crops is their secret sauce. And there are a lot of companies that go through various different forms of funding, but are encouraged to resell that data, or they're encouraged to use that data to train their own products to then go sell to this grower's competitors. It's a real problem in the industry, especially for the head growers in particular. They don't want their secrets to be shared. Really, they want them to be a little bit more insular. That's how they have job security. They can't kind of be automated away. So giving 100% data ownership back to the user was really, really important for us, and we've done a really good job of that, at least in the short term. As we onboard more beta and production customers, I'm sure we're going to run into issues, and we'll have to address those. But for the most part, the idea is you put data on the platform. We're not going to do anything with that data. We're not going to sell the data. We're not going to train any AI against that data. Anything will be scoped specifically to your data set and your user. And if you decide to leave us, you can take all your data with you for free, and we will help you migrate even and help you move to a different platform if that's what you wish to do. So as you can imagine, it's a lot different from several other platforms that you could get involved with. We also built a pretty generic dashboard. This looks like every other dashboard that you've probably ever seen. We try to keep it clean and nice and neat because the next step for us is to make it agricultural specific. So right now it's very generic and very broad, but we're going to be getting more niche down. This is actually an actual running device for the Twig. So when I pivot over to Lawrence is going to show you the physical device. I have one running in my kitchen right now, and this is the data that it gives me. And this is all running on the Moddable SDK and using MQTT. We have several different variations of endpoints. We have moved over to MQTT as time has gone on. But this is this is the dashboard. We're pretty proud of this. We've been using it internally for a while now, and we haven't had as much success getting a public launch really going. And we finally got boards down, and we have the ability to produce this hardware sustainably down and consistently. So now is the time that we're going to be doing our beta launch. And we actually shipped out devices right before this call. I shipped out our first devices to our beta customers, and Lawrence has got 50 to 100 devices he's building up as we speak, and we're working with crowd supply on some other things too. So with that, I'm going to transfer over to Lawrence because he'll tell you the fun stuff about the actual hardware.
All right, can you hear me okay? All right, sorry about that. I think, does everything look okay?
Looks good.
Okay, awesome. All right, so this is actually our very first board we've ever made. We actually started with the ESP32 Pico. This was actually in the middle of the pandemic, so Anybody who kind of remembered like the horrors of like all the parts that you needed to use were always unavailable. I actually ended up having like duplicate footprints for almost every single device on the board. That's why there's actually 3 different footprints for 3 different different types and manufacturers of temperature humidity sensors. Also why we originally went with a Pico, because actually it's the same footprint almost as the ESP32C3. So yeah, so this is actually one of our first like product market shots. It's literally just kind of sitting in my garden right there. And you can kind of see how it kind of looks in the field. Dangles on the USB cable, and it just kind of hangs inside with the plants. We went through, we used a variety of different, we basically went through a whole bunch of different processes to figure out what was going to work out best. We ended up using a combination of, for one round, both GLC PCB as well as OSH Park, as well as also custom stencils. So we've kind of been playing around with the idea of like we want to be vertically integrated for to maintain and keep that internal manufacturing knowledge in-house. But we also recognize that growth requires partners. And so we've been kind of walking that very fine, narrow road of using industrial partners to help, or manufacturing partners to help us grow, while still keeping all that knowledge in-house. And so these also started to generate and kind of get added to our marketing material as we kind of developed and pushed this along. This is one of the first rounds of from JLC PCB. They did a fantastic job. I think we had like an 80% yield, which is pretty good for a no touch buildup. And a lot of that informs the design as we go along, because you can actually like improve your design, improve your schematic and the layout to make it easier to build. So multiple manufacturers and multiple people building them all give us an opportunity to kind of like test out how different people experience our manufacturing tools and data packages to build things out. And over the time, we've kind of like bounced between, do we want to have USB-C, USB micro? Do we need, how many like GPIO lines do we need accessible? What's going to be the easiest to debug? This was also in the middle of the bring up for the ESP32C3 support. And if I'd done it over again, I probably would have just stuck with ESP32. But ESP32C3 has some really neat features with how it integrates JTAG directly into the USB stack, which I really liked. We took advantage of. We actually did something also that's kind of unique, is that we actually made our own molds for the injection molding, for the over molding for the boards. So these boards are in a waterproof or water resistant enclosure. But instead of doing like a custom 3D printed enclosure or potting with like epoxy or something else, we decided to use a high temperature hot melt type polyolefin, and that material actually has a lot of really neat properties for like low temperature, high temperature, as well as reflowing in case of damage, as well as be able to re-adhere if there is any kind of like mechanical break in the system. So we actually went through a whole bunch of iterative processes of building different kinds of molds, different 3D printing these, and actually putting them inside of a injection molding machine. You can kind of see like this is one that's not been injection molded, has been. As you can see, it's been kind of a process to learn the material and the material process, what works, what doesn't. This is one of our debug configurations where you have the serial lines exposed, and so we try to basically make it as much of a debug platform as well as a final finished product. So I think we kind of envision selling this as both like bare boards that people can actually hack on, and then final finished products that people can rework or can put into service. We also had a lot of fun learning about the differences in sleep modes. This is without sleep mode. That is with sleep mode. with something that's trying to determine the temperature of the room, that's really important. So, and as we went along, there's been a lot of like trial and error, just learning the process and just learning learning how to basically get the machine to work, all the processes in place. So as it's kind of interesting, like just the process of getting to this point took a massive amount of effort. And even still, there's still a lot of like fine tuning to really make a very solid product that still needs to be done at this point. So this is the molding by hand approach that you can kind of see. This is, I want to see if I could just do this as kind of like a last ditch effort. And it turns out you can. So the nice thing about these processes is that as you learn them, you can actually start, you have a lot of flexibility. And like, if I wanted to like make my own, what it would look like, you can do it actually by hand. And they aren't pretty, but they're functional. These are some of the iterations of the molds we've had. This is actually the first generation mold. These are the second generation mold. These are UV resin printed. We can kind of tell that one of them actually ended up breaking. These work really well, but as is, they still have a lot of processes to get in place. One of the things we're still struggling with and kind of deciding is like how much of the manufacturing documentation needs to go along back into the open source ethos of like of showing and telling and describing the process, because a lot of open source projects, like this information is never shared at all, but I feel like it's almost critical for the success of our product. So as we go along, I think we're going to have internally we're having dialogue about like what that's going to look like long term, and how we can start working with manufacturing partners and other people to really make this a truly open source project at all levels. And this, yeah, so this is older and newer model. And this is actually something that's also interesting. We're working on labeling for the back of our products as well. So this is actually like a test sample piece for printing with an industrial UV printer onto the back of our units. This is one of our better molds, and slowly you can kind of see like it gets better each time. This is actually the hot melt machine that we use. It's literally designed for making sealing up cardboard boxes. So we really kind of like are trying to walk that very narrow path of like of sustainability and scalability, while also being while using a technology that allows us to kind of like punch up above our weight in terms of what we can do. And I hate to say it, but we've done a lot of mold making, probably more than I'd like to admit. And yeah, so this is actually just the process of this is one of our latest boards. This is actually Rev 3. Rev 3, 0.3. Open hardware, we actually got the certified recently as open hardware with the Open Source Hardware Association. And we actually plan on doing one more revision on top of this to kind of clean things up finally. That's kind of like what it would look like if we were shipping these out today. One USB cable, one USB power supply, one device, one little pamphlet, and a mailer. And this is probably one of our, or closer to one of our final molds. You can kind of see that this is what it'll probably look like. You'll actually be able to see through the mold or the overmolding into the device. So I'm kind of really happy how this kind of turned out. We've got transparency both on the device as well as in the company. And it's come a long way since we started this process. So I'm really proud with all the work we've done. And you can kind of see like that's actually what the final product will end up looking like. The QR code and the serial number will all be referenced based on the internal serial number inside the device, so we can actually keep track of each of our devices. And that's it.
Okay. So when you say that's that, that's both of you are that's that.
Well, that's that. That's where we're at. Okay. That's what I've got in the presentation. I think Daniel has. Cool. Do you want?
Yeah, I wanted to take a moment and talk about specifically how Moddable helped in this process before we end our section, because it's terribly important and critical to to how far we've gotten and how fast we've gotten. Let me see if I can share my screen real quick. One second. Yeah, we'll do that. So Moddable in particular, we vetted several different platforms. We wanted to try to stay in a realm that we could find the most talent for, and having in particular, owning a dev shop, I've got a lot of web dev talent. So we're immediately pushing towards things like Python, pushing towards things like JavaScript with the Espresso tools and things like that. Lawrence has a background in C++, so if we had to bring out C and C++, Lawrence could do that, but I wanted to keep it as close to web related as possible. And in particular, what I really love about Moddable in particular is it's sticking to modern JavaScript proposals. We were able to go back and look at other JavaScript frameworks that are out there in the market, and they either have their own quirks or they're not running the latest like web-based standard, or there's just something nuanced about them that is different from actual web JavaScript. So Moddable's focus on being almost a one-to-one parity with web JavaScript it allowed us to get people up and running extraordinarily quick. My devs were able to onboard really quickly to the Moddable framework in particular, and then couple that with xsdev, which is relatively new. The install process now is basically seamless across devices, which is really powerful. We were having issues with some of the Espresso and ESP-IDF tools. There were some problematic installs going from like Windows to Mac, and we switched over to using Mac almost exclusively in Linux, and a lot of those went away, but some of them remained. The other thing that I was really impressed with was Moddable's kind of commitment to community. A lot of these platforms have their own really tight-knit niche community, but they're not trying to approach developers who want to build commercial products. So they're a little more geared towards your hobbyists or your enthusiasts, whereas when we want to produce a commercial product, we have to have really fine-grained control over the things we have to have fine-grained control over, like sleep, for instance, or writing C code when we need to. And I felt like every framework we went to outside of Moddable, we'd run into issues where, they would have Bluetooth, but it was only GAT. They didn't have BLE, or, they would have access to sleep, but it was only deep sleep. Or, instead of using Blue Droid, they only use Nimble, and instead of Nimble, they only use Blue Droid. And like one would use up too much memory, and it just went on and on. There were so many edge cases, whereas Moddable kind of gives you this platform where you can have really fast productivity coming straight out of web JavaScript for a normal web dev, coupled with really low level access to all of these hardware APIs, including C if you had to reach for it. So as an example of this, there's an open source platform called ESP Home. They came out with a Bluetooth onboarding process called Improv Wi-Fi. We wanted to have Improv Wi-Fi and keep it compatible with something open source. So I actually built this. I want to say it took me about a week, and I'm a web dev. I've never written anything in dealing with Bluetooth servers ever. It's never happened. I've never studied it. It's not my forte. And within roughly a week, I was able to get an implementation of their C++ library working in Moddable seamlessly. And this has been a backbone for our Bluetooth onboarding system, even to this day. So this is a testament to how far you can get with just JavaScript knowledge in like a hardware environment. And this goes back to the power of Moddable and its focus on their community, as well as giving low-level access to APIs. And then couple that once again, and huge shout out to Nick, xsdev has drastically improved the onboarding process. So now we have basically an NPM package that can get us up and running in a couple of minutes, and flashing devices and writing JavaScript code, which is extremely powerful. So I want to take a moment just to talk about that in particular, and how much Moddable has helped us with this. I don't think we would have got nearly as far, nearly as quickly, just in dev hours, had we not used the Moddable platform, period.
Yeah, there's a wonderful silence here at the Moddable office. Daniel, thank you for that. It's really great to hear. And Lawrence as well. You bring up something that Daniel is very much part of how we approach development, which is we look at this from a commercial perspective. You know, the XS is engineered as a commercial JavaScript engine. We as you know, as you explained so well, we spend a lot of effort to make sure that we support the web standards, as we talked about earlier, even obscure things like symbols as weak map keys, so that, you know, people who know and love that have it available, even if most people don't need it. You know, and so we are working with Agoric. We do a huge amount of work to fuzz test our JavaScript engine to make sure that there aren't security vulnerabilities or subtle instabilities that would get in the way of a product that has to run 24/7 year after year. And so that commercial aspect of it is something we don't talk a lot about especially in our community calls, but it's actually the backbone of our business and our development. And it's really great to see, Juniper, you and Lawrence kind of coming at our SDK from kind of the more open community perspective, but taking it into a commercial space. And I really like that you're sharing kind of the steps and missteps along the way. It's sometimes very easy to take a product and kind of pull it out and it's perfect. But of course, the reality is there were all kinds of challenges before that. And so I think you guys have done a really nice job showing people the process, and it's okay if the first and the second and the third one aren't perfect, because just keep learning. I'm curious about the open hardware certification. That's very cool. And and not altogether common. How big of an effort was that for you guys to get that certification?
Well, our files have been on like GitHub for the last year, so it's mostly just like pointing out that it's open source and that could you please give us the certification? And they're like, sure. And a lot of it's just kind of like, a lot of it's mostly just trying to figure out, like, because a lot of open hardware, it's the open source stops, and like, for example, all of our board design files are in KiCad, and all of our firmware that we've been developing we basically used a combination of ESP Home and Moddable to kind of bring up the board initially to test out ideas and test out different library packages and things like that. So I mean, from the beginning, we've been wanting to make something open, but also trying to make a business out of it too. So it's been we've had kind of like this idea of what we want to shoot for, or we want to go towards, because it is, and part of the reason why we went down this way in the first place is because there's not a lot of open IoT devices we can build a business on, and that are commercial grade and like industrial ready, that we could actually ship to a customer and expect it to be in the field for 6 months to a year with minimal number of return calls. So this is kind of our kind of like our calling card, as well as kind of hopefully our first shot in the dark to see who else wants to kind of start building on top of this, an IoT platform that's dedicated towards open transparency and open hardware. Because this is like just a piece of a larger ecosystem of devices. And I'm hoping that that as we start working towards a more general like marketplace of IoT devices, that we can have a plethora of things. Like, for example, when you go to your house, you look around your home and you look at like your light switches. If they're IoT, there's a good chance that your light switch will have to be replaced in 5 years. But if it's just a normal analog light switch, that thing should last like 50 years ish. Very few IoT devices or products in general are designed for that kind of lifestyle, or lifetime. So I want to build something that can last, that if we go under, the design files are still available, the device is still available, the firmware can live on. And then hopefully we can find other people that want to build on top of this kind of ethos, and build like a whole community of IoT devices where maybe we make some, somebody else makes some, but we've actually got a process for onboarding other customers' boards onto our system. So we could actually be servicing and providing like warranty and contract support for somebody else's boards. And we've got we can have business-to-business relationships for all those too. So this is all that is like super early, like super stuff that I'm really excited about, but like that's where we want to go.
I'll tell you something else where Moddable really helps out as well, which is the idea of these mods. And I am so excited to start playing with this because one of the outside of data ownership, we want people to own these devices. That's why the source files are open. That's why the schematics are open. And one of the parts of true ownership is the ability to modify things. So whenever I was going through and I saw things like compartments and web workers, and then I saw mods, and I was like, this is mind-blowing stuff. There's almost no other platform I've seen yet that allows you to modify the code running on a running device, and that is exceptional. And of course, we do it web, but on an actual physical piece of hardware, it's not something that's common.
You know, I think it's really exciting, and I'm glad you guys are kind of looking into that, because I think one of the ideas with mods is that it really reduces what somebody needs to know in order to customize the device, right? Because they don't have to rebuild the whole firmware. They don't have to have that whole tool chain. They don't have to work in C++. They can just take a few lines of JavaScript and very quickly flash it onto the device or download it to the device. And that's fundamental to our belief about where IoT needs to head. So exciting to see you guys thinking about exploring that. So cool. I love your presentation. I think really looking forward to seeing how the product evolves. I'm sure you'll keep us abreast of that. And I think it fits into lots of different directions that we're going, and folks in our community are. So really exciting. Thank you so much for joining us today.
Thank you.
Thank you so much for the invitation.
I'm going to briefly share my screen and just finish up here. Let's see if this will come up. Here we go. Just wanted to, I'm going to throw this up. I promise I won't read every line of it, but there's lots and lots of ways that you can connect with this community and give back to help folks out. And even something as simple as posting your questions or discussing ideas on GitHub really helps, or just sharing your project. So, you know, just think about how to be engaged, and you'll be surprised how many people are excited about what you're doing and can learn from that. There's been a couple of really great discussions on our GitHub repo lately that I just wanted to call out. They're probably both worthy of like extended conversations at some point. One is a demo by Thorsten. He got a Moddable 2 running with an IMU. But the super cool part is he's got it connected into real-time rendering of a rectangle, and the performance is amazing, and the code exercises all sorts of curious tricks about the Moddable SDK, including, at least in one revision, web workers, and a really, really interesting project. And I've learned a bunch by reading Thorsten's code, so give it a look. There's a long thread on GitHub at this point. Another one that's really interesting, and I mean a little more obscure but fascinating, is we have a developer in China at a startup there who's building some modules for use with the Moddable SDK, and they're doing it all in TypeScript. And kind of true to their background, they wanted to have unit tests to do continuous integration, which of course makes sense. They're actually running that on an emulator. This is on Linux using the I can't say it, QEMU emulator, so that they can run ESP32 code without an ESP32. And they set up a Docker image to do that. And that lets them do continuous integration. And that's super, super valuable. It's something that I'm hoping to get some time to look into more, because that's certainly something that we could benefit from in our own work. So these are just kind of, you know, the things that appear in our community that people share. Tons to learn, really interesting ideas. And so I encourage you to learn from these, but also, you know, start your own. So thank you for joining us. Always a pleasure.